What's going on, everybody? It's Kistner back again, and we're going to discuss section 1.6 out of your books and out of your student companion. So if you want to, you should have your student companion in front of you. If not, you're going to be doing a little bit more writing than the rest of us. And go ahead and turn to page, it says turn to page 21, but actually we're going to skip the explore and reason section and go right to example 1. So find example 1 on your student companion, try it, and find this problem. And if you have to, you can pause the video. But go ahead and get this out. We're going to talk about this. Solve each system of equations. Now, there are 3 ways of solving this system of equations. The 3 ways you have are elimination. I'll write these down in case you want to see them. 1 is called elimination, which we'll practice in a little bit. 2 is graphing. There's another, you can graph these and figure out how to solve them. And 3 is substitution. Okay, and I'm going to do substitution on this problem. So in order to substitute, I have to solve for one variable. So I'm going to solve for the y. I'm picking the y because it has a coefficient of positive 1. If that's the case, that's the best case scenario. And that's why I'm choosing substitution on this one. So in order to solve for this, I'm going to subtract the 2x from both sides of this equation. So this equation is now going to become y equals -1 minus 2x. And my other equation is still 5y minus 6x equals 7. So now I'm going to take, let me rewrite that just a little bit closer. I'm going to take this y and plug it in for this y. Substitute in. So what I'm really going to get is 5 times, instead of y, I'm going to write y -1 minus 2x. That is what y equals. And minus 6x equals 7. This is the bottom equation with the top equation plugged into it. Now go ahead and distribute your 5. You get -5 minus 10x minus 6x, still left over here, equals 7. Combine like terms, you get -5. Whoops, if I could write it help. You get -5. And then -10 minus 6 is a -16x equals +7. We're just doing algebra 1 now. We're going to add the 5. Get -16x equals 12. Go ahead and divide by -16, and x is going to equal -3/4. If you do that right, it's a -7.5. -3/4. It simplifies. Okay. So here's x. That's one of my answers. Now I need to know what y equals. In order to get y, I take this and plug it back into either equation. I can plug this x into either one of my equations. And I'm going to plug it in to this version of the equation because it says y equals already. Because I'm looking for y, I'm going to plug it into the y equals equation. Remember, I rewrote this. You could plug it into any of the other equations that we have. So now on this other side over here, I'm going to say y equals -1 minus 2 times -3/4. That's what x was, remember? And I get -1, oop, I can't write. Get -1 minus, and that's going to be positive, so this will be plus 6/4. And if I'm going to do this in my head real fast, -1 is 4/4, so -4/4 plus 6/4 is 1/2. So y equals 1/2. And here are my 2 points. You can leave it like this, or you could write it as an ordered pair. Like that. Okay? I will leave part B for us to do tomorrow in class because I'm going to do this one using elimination. in class next time I see you guys. Remember, I'm going to start leaving the B parts together. So, part 2 talks about graphing it. And notice these are different. These are all inequalities. Okay? Now, in your book, I don't know if you have the coordinate system, but I want to quickly point out that these bottom 2 inequalities mean all I'm looking at is my first quadrant. So what I'm going to do here is I'm going to import in just the first quadrant. Okay, I'm going to import in just the first quadrant, and that's all I really need. So let me go ahead and lock that in place so it doesn't move around. Now, I'm going to graph these things. So I know I'm in my X and Y coordinates. They're right here. Okay, let me line those up a little bit better. Where this is 0, 0. That's the origin right here. Okay? So go ahead and get your coordinate system set up that way. And I have 2 lines here that I need to graph. 2 lines. And I'm going to do it a little bit different of a way. Now, we're going to do some shading, so get ready to do a little bit of coloring, a little bit of overlap. I'm going to use different colors. You guys can use different slash marks. You'll see what I mean in just a second. But I'm just going to graph all 4 of these lines and shade where it tells me to shade. And the overlap is your solution. Where all these overlap will be your solution. So let's graph this first one. It looks something like it's that color. And the way that I do it, you can solve this for y and graph it with y equals mx plus b. But the way that I do it is I plug in my intercepts. I say, if x is 0, what is y? Y would be 14. Okay, y would be 14. I think there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's perfect 14 on here. When x is 0, y is 14. Because this goes away, and y is 14. Now, when y is 0, you divide, and you get x is 7. So when y is 0, 1, 2, 3, 4, 5, 6, 7, there's another point right here. I'm just graphing using my intercepts, remember. I'm trying to figure out what my x and y intercepts are. This is 7, 0. And now I have a line that I can connect. Okay, so let me get that up. So now I have this line. That was close to the right color. It's not exactly the right color. It might have been this one. There we go. Okay, so that's my first line. Now let's talk a little bit about it. It's solid. I know it's a solid line because of the equals to sign. And I know to shade underneath this line. I shade down on the y-axis because it's less than. Another way to do it is to plug in 0, 0. You plug in the origin, and it works. Then you shade over the origin. You shade towards the origin. So let me tell you why I'm saying that. If I plug in 0, 0, I get 0 plus 0, which is 0. Is that less than 14? The answer is yes. So I'm going to shade down here. Okay, I'm going to shade down here. Now, I know I'm kind of cheating with my highlighter here, but you guys can shade. I'm going to show you how you could do it. Okay, what I would do is I would take just my pencil and just draw vertical lines like this. Okay, I would just draw vertical lines. You don't have to color the whole thing in. Just say, oh, I'm shading down here. Because we're going to do that whole process one more time. We're going to do it for this orange line. X plus 2y is less than 10. Let me get an orange pen. So if I plug in 0 for x, that goes away. 2y is less than 10, so y has to be 5. So 1, 2, 3, 4, 5. I have this point. So that's 0, 5. Okay, and now if I go get my pen again, and I let y become 0, x is 10. So that's 7, 8, 9, 10. Here's this point, and this is 10, comma 0. So now let me go ahead and connect those dots. Okay. And once again, I know already I'm going to shade down my y-axis, so below this line on the smaller y's, because y is less than this. But you can always plug in 0, 0. 0 plus 0 is less than 10, so we're going to shade down here. So let me get that going. And as you can see, I get a weird looking graph when I use this highlighter, and that's the reason I'm using this highlighter, and I'm going to actually make it a little bit smaller. Okay, I'm going to get this weird looking graph in here. Now, I use these colors for a reason. First off, the book uses them. But if I shade everything below this orange line, you can see I'm getting more than just one color. More than just orange and blue now. Okay? Everything that's green is considered my answer. So everything in here is considered my answer. Okay? This weird trapeze looking green section, that is my solution set. It says graph the system, and I did. This right here is my answer. Where it overlaps is my answer. Now, if I'd have used lines, I'd have said these were vertical lines, and everything under this is horizontal lines, and where you make the grid is your answer. You can do it that way too. But I like to use different colors, or maybe light. Just use the light, like shade very light, and then color in really dark. But that's how you graph a system of linear inequalities. And I am going to hit that point again really hard in class. It's a lot easier when you see me doing it in class. Okay? But I just want you to see that. If you need to, pause the video, run it back, and watch that again. But I just graphed the two lines, shaded where it told me to shade, plug in a point, shade that point, and wherever my overlap is my answer. Okay, now, this right here is one of the toughest questions, not toughest, it's one of the longest questions we will ask all year. So what I'm going to do is quit the video right here and show you how to do this a little bit quicker in class tomorrow. Other than that, you guys make sure you've watched this video, you have done your in-class assignment that's ready for next class, and I will see you guys then. This is Kitchener out.